Alright, number 13. Let's find big F of 0. So big F is defined as the antiderivative of little f. So they gave us big F of 1 is equal to 9. So we'll want to use an x value of 1 and an x value of 0. And we're going to do the definite integral from 0 to 1 of fx dx. So that would be the antiderivative value at 1 minus it at 0. And we can calculate the exact value of the left side of the equation, and we know that f of 1 is 9. And then we can find f of 0. So how do we find the exact value of the left side of the equation? That's this value from 0 to 1. So from 0 to 1, it's a negative area, and it's a negative 5.5. All right, so what we want is equal to 9 plus 5.5, or 14.5. For f of 4, we do the exact same thing. We use the x value that we know and the x value of 4. So from 1 to 4, that's going to be the antiderivative of 4 minus the antiderivative of 1. And we know that this exact value is the area under the curve of f from 1 to 4. So from 1 to 3, we have an area of b, which is negative 6. And then from 3 to 4, we have an area which is positive 15.5. All right, if we just add 9 to the side, we'll have 18.5. All right, let's move on to part B. Well, if we make a graph of y equals big F of x, we know that f of 1 is equal to 9. We know that f of 0 is equal to 14.5. And we know that f of 4 is 18.5. We know that the graph of f is decreasing on 0 to 3 because its slope is little f of x, and the value of little f is negative from 0 to 3. So f itself is decreasing on the interval from 0 to 3. We know that from 1 to 3, the definite integral of little f of x dx is the antiderivative at 3 minus 1. And this area from 1 to 3 is a negative 5.5 and another negative 6, so negative 11.5. And that's antiderivative at 3 minus f of 1, which we know is 9. So f of 3 is negative 2.5. Let's graph that. So the graph of capital F, big F, is decreasing all the way down here, so it definitely crosses 5 once on that interval. Once x is 3, little f is finally positive, and that's the rate of change of big F. So finally, big F is increasing from 3 to 4, and it's always increasing on that interval. And we know that eventually it hits 18.5. So it's got to hit 5 twice. The minimum number of times that f hits 5 is 2 times. And the graphical representation, using the information we discussed, is a nice way to say that it's going to hit it twice. All right, what about part C? Well, as we've discussed in parts B and A, big F is increasing when its derivative is positive, and big F prime is little f. So our function is increasing whenever little f is bigger than 0, which means from 3 to 4. That's part C. All right, that's it for number 13.